A model can generally be thought of as having parameters that one wants to vary, and some standard analyses that are wanted for each variation. The common types of parameters that users wish to vary include material properties, position of parts, orientation of parts, and sizes or distortion of part shapes. This is the same Salt Quick Start model as in part 1 of AMPERES video. From the menu bar, select Solution, Define, Parametrics, then Parametric Setup. The Parametric Setup dialog will open. Click the Create button in the lower left corner of the dialog. The Parameter Editor dialog will open. The default parameter type, Geometry Displacement, is what we will be using, so we will not change this. However, you may wish to rummage through the list to see the various parameters that can be set up. Edit the name, steps, and target point. Click the Select Geometry button. The dialog will close while you select the geometry. Either use Volume or Object Selection and select the armature. When the armature highlights green, right-click to end selection. The dialog will reappear and the armature will appear green to indicate it is the geometry which the parameter will apply to. Click the Apply Create button. The Parametric Setup dialog will appear again, but with your defined parameter now in the parameters defined list. The geometry corresponding to the selected parameter, the only one in this case, is highlighted green. Click the Validate button to visualize what the setup parameter will do. The window should animate the armature moving upward in 5 steps, then return to the starting position. To visualize the total parametric setup, click the 2 arrows highlighted to toggle the display to the fully expanded dialog. The defined outputs don't appear under post-processing here. That list is for the temporary outputs that can be obtained from the analysis menu. In this model, we are interested to calculate force on the armature for different positions. Since it is already a part of the predefined outputs, we are not repeating this calculation through the analysis menu. Save this model and from the menu bar, select Solution, Run Parametrics, then perform parametric analysis. A dialog will open prompting you for a database name to save the results in. It is recommended to modify the name. The solver will now iterate through all the requested parametric variations. When it is done, the final parametric table will appear. Click the Graph Results button. Set the Graph Results dialog as shown. Click the Graph Results button. A graph will appear showing the force versus the parametric step number. Click the Close button for all open dialog boxes. To analyze the defined outputs, select Analysis, then Output Manager from the menu bar. In the pop-up dialog, and set the animation slider to the fast end. Click the Animate button. AMPERES will cycle through displaying your plots. Press the Escape button on your keyboard to stop the animation. When you have settings you like for an animation, you can use the Save Animation button to make a video file. To view plots from individual analysis, set the step number, then click the Show Step button. Scripting via the API is the other major way of automating the use of integrated software. Scripting takes more setup time than parametrics, but offers much more power. While parametrics are restricted to studying systematic variation of existing model parameters, scripting offers many more possibilities. To run a script for first time on your computer, some extra setup will need to be done. Close AMPERES and using Windows Explorer navigate to the folder when AMPERES is installed. Right-click on the file ies.exe. In the pop-up menu, click Run as Administrator. AMPERES will open in a special mode which sets up the Windows registry for external scripting control. Close AMPERES. The scripting examples are provided in a zipped folder placed in your document folders. Double-click on API Samples zipped folder. Inside this folder is a zip file, also named API Samples. Right-click on the API sample zip file and extract all. Navigate into the API samples folder. Double-click the Excel folder to open it and double-click the file Amperes Faraday-Halbach Wiggler sample to open it. If there is a security warning flashing, then click the Enable Content button. The spreadsheet shows some instructions in the first few lines, followed by some parameters and a Run Amperes button. Now start Amperes and click the Run Amperes sample button in the Excel sheet. While the macro runs, both Amperes and Excel will be locked. When the macro has completed, the spreadsheet will show a data table and plot of the Z component of magnetic field along the line from point 0, -12, 0, to point 0, 12, 0. You can try again by changing the parameters specified in the spreadsheet. This example shows a very quick limited use of scripting for direct comparison with parametrics. Similar targeted tools can be developed as scripts, but much more ambitious custom design tools even involving creation of the model can be created.